Hey, this is Brock Lemires, and in this video, I'm going to introduce decision statements in C, specifically the if-else statement. But before we can get there, we need to take a look at flowcharts and Boolean expressions. All right, so let's take a look. First of all, everything we've covered now has just been a sequence of statements. So we do a bunch of printfs, we do some operations, and then at the end of our main program, we essentially just end. So everything is executed once. A decision statement allows you to conditionally execute statements. So for example, you might have two different statements in your program, and a decision statement will look at some input or some variable value and decide which of those two statements will be executed. Okay. And so one of the ways that you describe kind of a program flow with decisions in it, and it makes it a lot easier to code, is using this graphical depiction of your program called a flowchart. And so in a flowchart, it's basically a graph, and you follow the flow of the program using arrows. And then you have these little blocks with shapes that actually mean something, and that's how you kind of design the algorithm of your program. And so you have an oval looking thing is your start and the end of your program. You have blocks, which represent statements or a sequence of instructions to accomplish a task. And then you have the decision diamond. And the way this works is that you'll have an arrow that comes in, and then based upon an evaluation of some statement, you will take one or more different paths out of the decision diamond. And then another shape is the subroutine or function, and that just has these additional lines on it. And we'll get to that once we start talking about functions, but these would be something separate that sits on the side that is called and executed. Okay, so here's an example of a state machine for a sequence on the left here. We have a start, we print a prompt, read a value from a user, do some operation, print it back, and then end. So that's very representative of everything we've done until now. Here's an example of a decision statement. Let's say that we start our program in main, we print a prompt for the user to enter a value. We read that in, and then with a decision statement, what we can do is we can say, is that information that was provided equal to something? And so in this situation, we'd say, was that equal to 0? And if it is, you'd say yes and move this way. Or if it was not yes, or in other words, no, you'd move this way. And you could do different values or different statements based upon the decision. So in this situation, you might print clear. In this one, you might print sent. Again, at this point, we don't even have the ability to repeat a program, such as loops. We'll get to that later. But this is how we can basically graphically see what is happening. Now, it's very important to think about decision statements. They are evaluated as true or false questions. Okay, so you basically you wouldn't say, is it green? You would say, is var1 equal to green? And the answer would be yes or no, or true or false. Okay, so to perform these true-false evaluations, C provides Boolean expressions. Now you might say, what's a bool? What's a Boolean? So Boole is actually a last name. It's the last name of a gentleman named George Boole. And he was a mathematician back in the 1800s. And he was the one that kind of came up with this whole idea of using two valued number systems in creating what we call logic today. So he kind of came up with the whole AND gate, OR gate, binary numbers, or how you would use binary numbers to actually perform something. So a lot of things are named after him. So a Boolean expression is what we call something in C that is evaluated as true or false. Okay. Now in C, we actually map true and false to actually numbers. And so true is a 1 and false is a 0. Okay. And then C provides relational operators that will allow you to produce the Boolean expression. Okay. And so you have 6 of these relational operators. So less than, greater than, less than or equal to, greater than or equal to, equal to, or not equal to. And you use these relational operators to form an expression that will result in what we call a Boolean expression. So the result of this is not an assignment. It's not going to manipulate any of the variables that are used. It is simply going to return true or false. C also provides logical operators so that you could combine multiple different expressions to form a more complicated Boolean expression. And so it provides an and, or, a not. Now notice that this is very important. And is an ampersand, or is a pipe. These are different than the unary operators that we looked at before, where you would use a single and percent, and that would physically alter the variable with an and operation. And same thing, if a single pipe will physically change the variable being operated on using an or operator. Same thing with not. We use the tilde to do a complement. These are only used for Boolean expressions. So this is something where you might say, is A greater than B and is B less than C. All right, so we use these logical operators in combination with the relational operators to just form more and more complicated expressions. Okay, now why are we, one last thing is now that we're starting to add more and more operators and comparisons into our kind of set of skills here in C, we have this growing list of what gets priority when it's evaluated. So now what we have is, notice that unary operators are still the highest priority, but that includes the logic operator, the pound, which is the not. So this will be in kind of the top group. Okay, so one of those little fellows got promoted. Then always at the bottom is the equal. So everything gets evaluated first, and then it gets assigned using equal. But here's where your relational and logical operators are. So they're sitting down here at 4, 5, 6, and 7. Notice that the and has more priority than the or. Okay. All right. So now we finally have the background in order to look at the first decision statement in C, which is the if statement. So what you do with an if is the syntax is literally if, and then you put in parentheses a Boolean expression to be evaluated. So in this situation, we have, as an example, is A greater than 22? The way that you think about this Boolean expression is this is going to evaluate to be either true or false, nothing else. There's no other possible value that this will return. It is not assigning anything to A. It's not doing anything other than saying, is this condition true or false? If it is true, it will execute what is contained within the curly brackets. So we open a curly bracket and then we close a curly bracket, and then we can have one or more statements that is in here. In this simple situation, if A was greater than 22, you would say this is true, and it would print this statement. Okay, it would execute the statement. If it was false, it would simply not do the statement and it would just exit. So this is like a do it or don't do it. Okay. All right. We also have the ability to include an else clause. So we can have a situation where if this Boolean condition is true, do this statement. If it's false, do this one. So the way that you tell it to handle the false situation is with the syntax else. Else is the same thing. Open curly bracket, close curly bracket, and then you do this statement. So in this situation, you have two statements. This one will be evaluated true. This will be evaluated if false. In the prior one, let's go back up. This only will be evaluated if it's true. Otherwise, nothing will happen. Okay. In this situation, it'll be like, if it's true, this will happen. If it's false, this will happen. Then you can nest if else's by simply putting another if statement after the else portion of the first if statement. So you can nest these together to start checking multiple conditions. So if I track this example, I would say if A is equal to or greater than 22, do this. Otherwise, that means it's false. So you'd come down here, then you insert another checking situation with the if statement. You'd say if A is less than 22, then do this. And then you could say else, do this. So this gives you the ability to check two conditions before you do the false case for the entire thing. Okay, so let's code along and let's do this example. So the logic for this is basically we're going to start our program. We're going to ask the user for a value using scan. We'll print something, say, give me a value. We'll read it using scanf. We'll print back what they printed. And then what we're going to do is we're going to do a comparison where we say, is the value greater than 22? If it is, print A is greater than 22. Otherwise, do another nested if else and say, is it less than 22? If it is, print A is less than 22. Otherwise, go ahead and print A must be equal to 22. And then we will end. Okay. All right. So here we go. I got my shells here logged into the Linux server. And what I'm going to do is, let me make sure I use the same file naming convention. So what I'm going to do is take a look at where I'm at. I'm going to make a directory called mod 05 code along. And then I'm going to change into that directory. And I'm going to go ahead and say cd mod 05 tabbed autocomplete. And then I'm going to do a new source code called if decisions.c. Okay. All right. So now I'm in Vim. Let me give myself a little bit of room down here. All right. So first thing I'm going to do is go into insert mode by hitting I, and I'm going to put my comment header, and we'll go ahead and say if statements. Okay, so we don't have to have a full comment header since we're just coding along. And I'm going to include the standard IO header file by doing pound include, and then I go stdio.h. Then let's start our main function. So I'm going to go int main void open curly, come all the way to the bottom, return 0, and then close curly. All right, now I'm going to go ahead and save that. And now I'm ready to do my program. Okay, so I'm gonna come up here and I'm gonna do the following. I gotta prompt the user for A, read A. So I'm gonna need some variables on how to pull this off. All right, so here's what we're gonna do. We are going to, first, we need a variable called A. And so we'll do int A. And that's going to set up space in memory, 32 bits in memory, and treat the information as a 32-bit signed integer. And then what I'm going to do is I'm going to say prompt user for values of A. And then what I'm going to do is say printf and then say enter a value for A. Okay. And then I'm not going to put a return right there. That's just a print statement. Then I'm going to do a scanf. Okay, scanf, and I'm going to bring that in using a format specifier of %d, which means treat what they give you as an integer and stick it in the location of A in memory. Okay, so that's that. Then what I'm going to do is say, I'm going to print that back. Okay, so I'm going to say printf, and then I'm going to say you entered, and I'll say A is equal to, and then I'll do format specifier %d, which means print it as an integer in decimal format, and then I'll do a line return, and then I'll put into that format specifier right here the value that's held in A. At this point, let's test that. Okay, so we've got everything in there. We gotta make sure that runs. So let me bring over my second shell. And what I'm gonna do is come down here. I am in my home directory. I'm gonna change it to mod 05. I'm gonna hit tab to autocomplete. Check out what's in there. There's my code, if decisions. I'm gonna say gcc if decisions. I'm gonna hit tab to autocomplete. Then I'm gonna go -o and direct the output into if decisions. Since this is the first time, I'm gonna autocomplete and then just remove the .c. So I run that and it's go. So now let's see what's in there. It's there, my executable's there. Now what I'm gonna do is I'm gonna run it with warnings all on and make sure I'm clean. All right, so I'm clean here. And what I'm gonna do is clear this up and let's run our program. So I'm gonna go Sunny Holland, meaning look in this directory for the executable, not search the Linux path. And I'll go ahead and do that and enter a value for A, say 22, you enter 22, life is good. We now have a code, we now have a program that is up and running. Now we can enter in our decision statements. So let's go ahead and do this. So I'm gonna come over here and I'm gonna say, all right, here we go. Here's the decision statements, okay? So I'm gonna go like this. I'm gonna say, if A is greater than 22, open a curly and say printf, and then I'll say A is greater than 22. And then I'll go ahead and put a line return. And then I'll do close curly. And then what I'm gonna do is say else if, and then I'll say A is less than 22. And then I'll open a curly and I'll say, go ahead and printf A is less than 22. And then I'll do a line return. And then I'll say else, gotta close my curly. And then that curly didn't line up very well though. Let me do this. Curly, and then I'll say else. Gotta open your curly. Open that curly and say printf. And then if those two conditions are not true, it has to be 22. So I'll put a return. Boom. All I gotta do, whoa. All I gotta do is close my curly. Life is good. All right, so there we go. Let's go ahead and test this. Let's compile it. Looked good. And go ahead and run it. Enter a value for A. I'm gonna put 22. You enter 22, A is equal to 22. So that statement verified that this case was correct. Now let's run it again and let's walk through the beginning. Let's do a number that's bigger than 22. So let me do 23. Okay, you entered A is equal to 23, A is greater than 22. That means it saw this Boolean expression evaluated as true, and it printed this one, and then it jumped out and you were done. Okay. All right. Let's do one where it's less than 22. So let's go 21. You entered 21. A is less than 22. So that means this was false. So then it jumped to the else clause. It evaluated this if, and it said, oh, it is less than 22. So it evaluated this as true. Then it said it jumped over and was out. Okay. All right. And then the last case, which we already did, was 22. This was false. So it jumped to here. This was false. So it jumped to here. And that was that one. It printed A is equal to 22. Okay, that is awesome. Now let's do one other one where we can use the, let's do this one. Let's do logical operators to combine two expressions, relational expressions, into something a little bit more complicated. Okay, so let me do this. I'm going to come up here and let's see, I'm going to comment this whole thing out. So I'm going to go boom, boom. Boom, boom. There's easier ways to do this, but for now, I'm just going to comment it all out and then start over with this new one. Okay. So life is good. All right. So here I am, and I'm going to do this. I want to check whether A is equal to 22 or 109. So if it's either equal to 22 or 109, it's going to put A is either 22 or 109, and then otherwise it'll say A is neither 22 or 29. So it's very simple. I just do it again. If, and then what I do is I'm going to open up parentheses. Okay. And then within here, parentheses are really important. They really keep things straight. So the first thing is I'm going to go A, is it equal to 22? And then I'm going to say, or using a logical operator, A equal to 109. Okay. Now this is a common mistake in C. If you accidentally do that, that's an assignment operator. It will actually make the assignment, and I think it'll return true. So you'd never want to do that because that is not the right operator. You always want to use the double equals because that's the relational, or it's actually the equality operator, but it's part of these operators that produce a Boolean return. Okay. Open a curly. If either of those is true, print F. A is either 22 or 109, and then return that, line return, and then else, and then let's clean that up. Actually, do this. Let me close my curly, and I can also put the else after the curly, which it kind of cleans it up a little bit. Otherwise, I'm going to put A is neither 22 or 109, and let's go ahead and close that little fella up. Let's line return it, not be it, line return it. And then we close our curly and save it up, and let's run that thing. So let me clear this fella. GCC it up. Life is good. Run it. And enter a value for A. So I'm going to put 22. You entered A is equal to 22. A is either 22 or 109. So what happened is it evaluated this Boolean expression as true. It evaluated this expression as true. This one was false, but since this was true, the OR operator said this entire Boolean expression for the if is true, so it printed that one. Now let's do the case where I enter 109. So I'm going to go 109, and it's like you entered 109. In this situation, this part of the Boolean expression was true. So with the OR operator, the entire thing was true, and it evaluated that expression. And now let's do one that is not. So let's go 99. You entered A is equal to 99. A is neither 22. So it said neither this is false, this is false. So this entire Boolean expression is false. So it said, I will not execute this part. I will jump to the else part and print that little fella. All right, that is if-else statements, but more importantly, that's the Boolean expression with relational operators, equality operators, logical operators, and also flowcharts. All right, that's it. See ya.